Hey, what's up everyone? Today we're diving into some physics MCQs, so grab your notes and let's get started. Question 1. When two bodies are made in thermal contact having the same temperature, they are at Option A, physical equilibrium. Option B, thermal equilibrium. Option C, mechanical equilibrium. Option D, chemical equilibrium. Pause the video and take a moment to think about your answer. Correct answer, Option B, thermal equilibrium. Explanation. Two bodies in thermal contact at the same temperature are said to be in thermal equilibrium because no net heat transfer occurs between them. Question 2. The normal temperature of a human body is 98.6 degrees Fahrenheit, while the atmosphere's temperature is 84.6 degrees Fahrenheit. What will be the temperature of a dead body in such an atmosphere? Option A, 84.6 degrees Fahrenheit. Option B, 98.6 degrees Fahrenheit. Option C, 92.5 degrees Fahrenheit. Option D, 185 degrees Fahrenheit. Think about it before moving forward. Correct answer? Option A, 84.6 degrees Fahrenheit. Explanation. A dead body eventually reaches thermal equilibrium with its surroundings, so its temperature will equal the atmospheric temperature. Question 3. When the system is expanded by adding heat energy, the work done is Option A, positive and on the system. Option B, negative and on the system. Option C, positive and by the system. Option D, negative and by the system. Stop the video and make your choice. Correct answer, Option C, positive and by the system. Explanation. When heat energy is added, the system expands and the work is done by the system on its surroundings. Work done by the system is considered positive. Question 4. Which substance possesses the largest internal energy at a given temperature? Option A, solid. Option B, liquid. Option C, gas. Option D, all of these. What's your answer? Pause and decide now. Correct answer, Option C, gas. Explanation. Gases generally have the highest internal energy at a given temperature because of their greater molecular kinetic energy compared to solids and liquids. Question 5. Internal energy of a substance is defined in terms of Option A, pressure and volume. Option B, pressure and temperature. Option C, temperature and volume. Option D, pressure, volume and temperature. Take a moment and figure it out. Correct answer, Option C, temperature and volume. Explanation. Internal energy depends on temperature and volume since it is related to the microscopic kinetic and potential energies of particles, which are influenced by these factors. Question 6. The ratio between work done and heat energy is equal to Option A, adiabatic constant. Option B, Joule's constant. Option C, specific heat constant. Option D, real gas constant. Pause here and make your choice. Correct answer, Option B, Joule's constant. Explanation. Joule's constant is the conversion factor between work and heat energy, demonstrating their equivalence in thermodynamics. Question 7. A system which transfers neither mass nor energy is called Option A, open system. Option B, closed system. Option C, isolated system. Option D, non-cyclic system. Correct answer, Option C, isolated system. Explanation. An isolated system does not exchange either mass or energy with its surroundings, making it completely self-contained. Question 8. The first law of thermodynamics is based upon the law of conservation of Option A, mass. Option B, energy. Option C, momentum. Option D, charges. What do you think? Option B, energy. Explanation. The first law of thermodynamics is essentially the law of conservation of energy, stating that energy cannot be created or destroyed, only transformed. Question 9. A process in which all the heat energy is used for increasing internal energy of the system is known as Option A, isobaric. Option B, isochoric. Option C, isothermal. Option D, adiabatic. Pause here and think it through. Correct answer, Option D, adiabatic. Explanation. In an adiabatic process, no heat is exchanged with the surroundings. Any added heat energy increases the system's internal energy directly. Question 10. In which process the internal energy is used for doing work? Option A, isobaric. Option B, isochoric. Option C, isothermal. Option D, adiabatic. Make your guess before continuing. Correct answer, option D, adiabatic. Explanation. In an adiabatic process, the work done by the system comes entirely from changes in its internal energy. Question 11. The specific heat of a gas in an isothermal process is option A, 0. Option B, remains constant. Option C, negative. Option D, infinite. Think for a moment and choose your answer. Correct answer, option D, infinite. Explanation. In an isothermal process, temperature remains constant, meaning that the heat capacity is theoretically infinite, as any amount of heat does not change the temperature. Question 12. A process in which the system remains at thermal equilibrium is known as option A, isobaric. Option B, isochoric. Option C, isothermal. Option D, adiabatic. What's your answer? Hit pause now. Correct answer, option C, isothermal. Explanation. An isothermal process occurs at a constant temperature, maintaining thermal equilibrium throughout. Question 13. The value of the adiabatic constant for a monoatomic gas is option A, 1.40, option B, 1.44, option C, 1.60, option D, 1.66. Take a moment to decide your answer. Correct, option D, 1.66. Explanation. The adiabatic constant for a monoatomic gas is given. For a monoatomic gas, the atoms can only vibrate in one direction and do not rotate, so the internal energy of the gas is proportional to the temperature, and the specific heat capacities are given by. Therefore, the adiabatic constant for a monoatomic gas is 1.66. Question 14. The efficiency of a heat engine will be 100% when option A, the engine takes a huge amount of heat from the source. Option B, the engine exhausts a very small amount of heat to the sink. Option C, the temperature of the cold reservoir is 0 degrees Celsius. Option D, the temperature of the cold reservoir is 0 Kelvin. Pause and think through this one carefully. Correct answer, option D, the temperature of the cold reservoir is 0 Kelvin. Explanation. According to Carnot's theorem, maximum efficiency is achieved when the sink is at absolute zero, which is practically impossible. Question 15. The second law of thermodynamics provides the proper direction of option A, temperature, option B, force, option C, pressure, option D, flow of heat. What's your guess? Decide now. Correct answer, option D, flow of heat. Explanation. The second law of thermodynamics states that heat flows spontaneously from higher to lower temperatures, giving the direction of heat transfer. Question 16. A device which converts mechanical energy into heat energy is known as option A, heat engine, option B, Carnot engine, option C, refrigerator, option D, turbine. Pause here and choose your answer. Correct answer, option A, heat engine. Explanation. A heat engine converts thermal energy into mechanical energy, but during its operation, some mechanical energy is converted back into heat due to inefficiencies. Question 17. Question 17. Entropy of a reversible process. Option A, decreases. Option B, increases. Option C, infinite. Option D, 0. Think carefully and make your choice. Correct answer, option D, 0. Explanation. In a reversible process, entropy remains constant because the system is in perfect thermodynamic equilibrium at all stages. Question 18. Entropy remains constant in the process of option A, isochoric, option B, isobaric, option C, isothermal, option D, adiabatic. Pause and finalize your answer. Correct answer, option D, adiabatic. Explanation. For a reversible adiabatic process, no heat is transferred and entropy remains constant.